I'd like to talk about subnets and VLANs. Both of these are logical divisions of a network. They allow us to take one network and divide it into smaller parts using different techniques. A subnet is a shortened way to say subnetwork, and it's a part of the IP version 4 standard. So IP4 supports multiple subnets. VLAN is an acronym. It stands for Virtual Local Area Network, and it is typically going to be handled by a switch. So in talking about subnets, we'll need to talk about a subnet mask. When you see an IP address, another piece of information is often presented, and that is the subnet mask. Lots of different subnet masks are possible, but 3 of them are by far the most common. These subnet masks are very common. They're all a combination of the number 255 and the number 0, and you'll notice they're organized into 4 sections, just like the IP address has 4 octets. The subnet mask also has 4 octets, separated by periods. The subnet mask tells us which part of the IP address is being used for the network and which part of the IP address is being used for the host. So any place we see 255, that means the corresponding octet in the IP address is being used to specify the network portion. And any place we see a 0 in a subnet mask, that means the corresponding spot is being used to specify the host address. Let's go through a few examples. So an IP address of 192.168.1.25 and a subnet mask of 255.255.255.0. The subnet mask tells us that the first 3 octets of the IP address are going to be used to define what network this machine is part of. So our network is the 192.168.1 portion of the IP address, and the host is the whatever is left over. So all we have left is the 25. So the host is number 25 on the network 192.168.1. Another example, an IP address of 10.15.12.1 and a subnet mask of 255.0.0.0. The subnet mask having only 1 occurrence of 255 tells me that the IP address, the first octet, will specify what network we're on, and then everything else after that will be the host. So this would be the 10 network, and the host would be 15.12.1. We could also look at the same IP address with a different subnet mask. So again, 10.15.12.1 for the IP address, a different subnet mask, 255.255.0.0. So now the first 2 octets of the IP address are the network, and the last 2 are the host. So the purpose of the subnet mask is to communicate which part of the IP address is the network and which part of the IP address is the host. Next, we'll talk a little bit about VLANs. VLANs are configured on the switch. Each port on the switch belongs to a certain VLAN. By default, they all belong to VLAN 1, but you can change that. We can make a port belong to a VLAN with any number between 1 and about 500. It varies on different switches. The switch only allows communication within the same VLAN. So if we have 2 ports that are on the same VLAN, those 2 machines can communicate with each other. But if we have 2 ports that we have tagged as separate VLANs, then those 2 ports cannot communicate with each other. This can certainly make things more secure. We can prevent certain ports from communicating with other ports. It also allows us to run multiple networks through one device. So if you'd like to run 2 networks, you don't necessarily have to go out and buy 2 switches. You could, for example, take port 1 through 10 and make them part of VLAN 1 and plug in all of one network into those 10 ports. And then make port 11 through 25 a different VLAN, say VLAN 2, and then plug in all of the machines on your second network into those ports. And as far as the switch is concerned, those are 2 totally separate networks. The switch will not automatically move traffic from one network to the other network, so these things will continue to operate independently. If you need traffic to flow from one network to the other network, you can accomplish that by adding a router. Typically, VLANs and subnets go hand in hand. Each VLAN will support one subnet, and each subnet will exist only on one VLAN.